Yeah.
Is it like use extra resources or something? Because I have a really weird GPU setup. And that was what was.
Maybe even for whatever I want.
Huh?
Whoa, Hucky, your camera looks really different today.
Droid cam. Or are you actually on your phone?
All right, now we just wait.
Now we wait. Should we ping the Discord?
Really? I mean, there's nothing to lose there.
That's true.
I guess while we wait, I'll post the link to the GitHub in the chat. So obviously there's gonna be a lot of coding today. So if we are like kind of time crunching, we'll probably just like copy and paste sections of the code from the GitHub. And that's the case. The links in the chat, I'll paste again for the people that just joined. And also, we're going to be downloading a 3D model for one of the code today. That's also hosted on the GitHub. So I guess either way, you'll want to make sure you can access it. All right. How much? I guess we should roll it like 2 or 3 extra minutes. Oh, 18 people. And counting. Should play some like elevator music in the meantime, just to kind of make it not absolute silence. Okay, that was too loud.
The iconic Tomoki elevator music.
I recently found this YouTuber that like plays like sort of elevator music at a really low volume throughout the entire video. And I noticed it actually makes it sound like not boring. So I was thinking maybe like from now on, every meeting, we should have like a little background music playing through the entire duration to make it a bit more cheerful. Okay, this better not blast music at like crazy volume. Do you guys all hear it? Is it too loud or too low? My intention is to kind of make it like the Wii Shop background music, just kind of like subtly playing the background to kind of bring up the spirit, I guess. All right, 6:03, so I guess like 30 more seconds and we'll get started. All right, so for those who just joined, let me paste the link to the GitHub. You don't really know how to use GitHub or anything. We'll show you like as we go. So again, no sweat if you've never seen GitHub before. Just make sure you can open the link and see the code. Ooh, low, high, or low. Okay, my pronunciation is screwed up today for some reason. Oh, thanks, Max. Oh, lo-fi hop. Hopefully the video doesn't get copyright striked. All right, I think we can get started now. I think I'll stop the music after all because I just got feedback that the sound's kind of choppy. All right. Okay, so welcome everyone. So this is the Design Tapas WebGL workshop. And without further ado, I'll start sharing the Google Slides. Hold on, I accidentally closed the tab, so I have to open it again. Hold on a second, please. All right, let me begin screen sharing. All right, you guys all see it? All right, so again, this is the WebGL workshop. And first off, so what is WebGL? So based in really short words, WebGL is technology that allows you to make really cool graphics on your website. So usually it's 3D, but you'll also notice there's also some 2D stuff. So WebGL also allows websites to render 2D graphics really fast. So that's why software like Figma actually use WebGL to help them render all these like mockups really fast on the website. My beating's kind of tilting. Oh, and also I should probably share the link to the Google Slides so anyone can see it. I'll drop it in the chat. There you go. All right, so what exactly is WebGL though? So in short, it's a set of code, or if you're more used to computer science terminology, basically an API that allows web browsers to access your computer's GPU or the graphical processing unit. So basically any code running in a website can use WebGL to access your computer's GPU and render graphics faster compared to like just using the CPU. So cool. So now that we know what WebGL is, we can make cool graphics, right? Well, not quite yet. So the problem with WebGL is that it's really, really limited. But the basic features are mostly for rendering lines and like really, really basic shapes like triangles. So if you were to make like really like say if you want to make a video game, you'll have to like manually specify like all the points in like a 3D model and like basically do all the mathematics required to orient the object in the 3D space, write like a bunch of code to simulate physics, to like simulate the behavior of photons, to like make, say, like water. And also simulating physics is, pretty a computationally expensive process. So you'll want to use some CS knowledge to optimize the code and make it run faster. All of which obviously is a lot of work. It's a lot of pain, it's a lot of math, it's a lot of physics. Nobody likes that unless I guess you're a math major or a physics major. So that's where this library called Three.js comes in. So Three.js is like one of the many libraries that use WebGL. And what this does is it basically kind of allows you to use WebGL technology more easily. So as a starter, it does all like the complex math, physics stuff that I just told you about. It does it for you. Someone just said I should do the presentation. Is the presentation mode working? I just went full screen. Okay, I'm gonna assume it's working. So as I was saying, it does all the complex math, physics stuff for you. It comes with basic shapes like cubes. So if you didn't use Three.js, what you would have to do is like manually specify all 6 points in a cube using like code. That's a lot of work, obviously. Whereas in Three.js, you can basically like make cube and it'll do that for you. And it also comes with basic shaders. So let's say you want to make like some metallic shiny surface. If you didn't have Three.js, you'll have to write like a bunch of code to like simulate how photons would behave on like a shiny surface, like come in at an angle alpha, then reflect off by angle alpha, do all those complex calculations. Nobody likes that. Whereas in Three.js, you can say like make a metallic surface basically, and it'll again do that for you. It also comes with a lot of common features that you'll probably need if you're making a 3D scene, like cameras, lighting, stuff like that. Alrighty. All right, so before we dive into Three.js and WebGL subsequently, there's some basic terminologies you'll need to know. There's not a lot, there's only 6. So the first is called a mesh. So that's basically just 3D objects in your scene. And material, that's basically how the surface of the objects look like, e.g. glossy, transparent, diffuse. And light, as the name implies, that's the source of illumination in your scene. Like maybe you'll have like a sun in your scene, so like illuminates the whole world. Camera, that's basically the camera, aka the POV of the user. And a scene basically has everything of those. So a scene contains mesh, all the materials, all the lights, the cameras, etc. Kind of bundles it into like a one scene. And what a renderer does is it basically takes a scene and it spits that onto your screen. So let's say you have like a scene with like a flower and a sun. If you feed that it's a render, the render will like do all the calculations and like all the mathematics, computer science stuff necessary to actually display a flower and like a sun on your screen. Again, this will come back every now and then while we code. So if you're kind of confused, you can kind of open the Google Slides on your own computer and go back to the slide. All right, so let's actually get started. So I think in the event page, we asked that you kind of prepare a text editor beforehand. So in whatever text editor you decided to use, create a file called index-0.html. It can actually be any name you want, but I guess just for the sake of consistency, it'll be nice if you can name it index-0.html. And also, if you can, open this link right here. It's the GitHub. Again, this is the GitHub that contains the code for our workshop. So if you ever get stuck or if you need a reference, you can open it and just copy and paste the code. Okay, so let me actually switch to a new screen, which is my VS Code. Do you guys all see it? All right, let me open the participants view. And does anyone not have like a code editor? Like want me to kind of wait for like a minute or so before I move on? Everybody cool? Can anybody give us like a thumbs up emoji? You're all set to go on. Okay, I see 2. Oh, I see a lot more. All right, I think that's enough to assume y'all are ready. Okay, let me try to move this window to the center of my screen. All right, so to kick things off, let me actually open the GitHub link of my computer as well, so I have a reference. Okay, so again, to kick things off, first this is an HTML file. You can't run JavaScript in HTML file as it is. So first we have to make a tag called script. And close it off. So we're going to write our JavaScript code within this script tag. The next thing we have to do is import Three.js, the library. So to do that, we're going to copy this line. I'll paste this in the chat because obviously you guys don't want to type out the whole URL manually. So this line, again, imports the Three.js library. I guess a quick, like a side note is that the way I did it right here directly downloads the Three.js library from this website called package.com. Usually if you know more about JavaScript, what you'll do is you'll use like a framework, like you'll use like npm to install Three.js, or even download the whole library manually beforehand, and then kind of link it locally. But this method isn't really recommended because of performance reasons, but it's also the simplest, so that's why we're using it this time. All right, so the next thing we're going to do is we're going to add a function called window.add event listener. And load and function. So what this is basically says when you load the web page, run this function. And this is important because usually when you have JavaScript in your website, like let's say you're like moving a circle to give it animation using JavaScript. If the JavaScript code runs before the website is loaded, it won't be able to find that circle you're trying to animate. So let's say like, hey, where's the circle that I'm supposed to animate? Can't find it. Error. So in other words, you want to run your JavaScript code after the website loads, and this is what it does. It'll only run whatever code that's in here after the website has loaded. All right, so first off, what we need is a canvas. So it's literally a canvas. This is where we're gonna render our animations and cool 3D scenes. I guess cool is kind of like subjective, but it's where we'll render our scene. And this, so we haven't made a canvas in our website yet, but once we do, what this code does is it'll say the variable canvas will refer to the canvas element in our website. Okay, I have a lot of typos. I do make a lot of typos if you haven't noticed yet. So please feel to unmute and shout out if you notice anything. All right, so we also need a renderer. So if you remember, renderers are the things that we use to take a scene and render it out. So for this, we say WebGL renderer and canvas. So basically, this tells that the renderer should spit out whatever thing it renders onto the canvas. Okay, so the next few lines, it's actually a bit cumbersome to type out, so I'm going to paste it into the chat again. But what this basically does is it sets up the camera. So you don't really have to understand what all these variables mean because they'll kind of get too complicated for the context of this workshop. Just know that these are like parameters to set up the camera, and this context camera equal new 3 perspective camera. This actually creates the camera. And usually cameras are like, looking down from like a high position. So that's why we say camera.position. Or it should be y actually. Y equals 2. So that's kind of positions the camera at like a high position. In this case, 2 units up from the ground. Okay, so now we have a camera, we make a scene. So constant scene equals new 3 dot scene. S should be capital. Again, this instantiates the scene. Like, and anything we need in our scene, lights, objects, we put in a scene. So first off, we want to make a box. So we say const geometry equals new 3 dot box geometry. And we're going to say 1, 1, 1. So it's like a standard box the size of 1 by 1 by 1. Nothing special. And if you remember, we also need a material. So we have to tell what this box's surface should look like. Should it be shiny? Should it be not shiny? That is all determined by the material. So we say const material equals new 3 dot mesh basic material. And it turns out the basic material is pretty basic, as you'll see, but we'll fix that in a later section. So we specify the color. You can specify using text. So in this case, I'll make it red. So it'll be FF0000. That's red. In case you've never seen hex color, how it works is the first 2 digits stands for red. The second 2 stands for G. The third stands for B. And you count up. This is a hex, so the numbers aren't 0 through 9, it's 0 through F. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, or no, sorry, 9, and then A, B, C, D, E, F. It's kind of confusing, so if you don't really understand it, you can forget what I just said. But the bottom line is this color is red. All right, so now that we have the geometry and the material, we can actually create the object. We combine the two into a one object called cube. So we say cube equals new 3 dot mesh geometry and material. All right, and then we want to add this cube to the scene. So we say scene dot add cube. Okay, so I'm also going to paste this into the chat. If you can see, there's a function called render.
Okay, I think someone had a question in the chat a little earlier.
Oh, wait, sorry, I think I missed it. Are there other constructors for perspective camera with us? Oh, yes, there is. So I believe, if I remember right, these 4 are mandatory, but there's like also other parameters that you can like optionally set up, but you rarely use them, to be honest. So it's pretty much optional. Oh, yes, thank you, Kevin. Yeah, so if you really want to know what they are, there's a documentation to the camera you can check out. Right, so let me, oh, wrong. So first, paste this function in. Oh shoot, my mouse is about to die. Please don't die on me. Okay, so what this function is, it's a function that basically executes every frame. Okay, so a bit of background on what request animation frame is. So in the early days of JavaScript animations, how people used to do it was basically they'll set up a function that, say, runs every like 100 milliseconds. And they'll say like, okay, every 100 milliseconds, move this box 1 unit to the right. If you repeat that, you get an animation. But the problem is computer screens actually don't refresh at a constant rate, or at least internally. Like say if you're, if you're running a game, if you're just running one website, they'll run at like 60 FPS. But if you have like 20 YouTube videos running in the background, if you're mining Bitcoins or something, it's gonna run slower. So it's gonna say drop to like 20 FPS. So the frames per second really varies depending on the situation. So to compensate for that, request animation frame basically moves, like plays an animation only if the screen is ready to render a new frame. So in other words, if the computer is like is running really well, if it's like 60 frames per second, it'll run this function 60 times per second. But say if the computer is really slow, and it's like, again, if you're mining Bitcoins or something, and it's like 10 frames per second, it'll run this function only 10 times per second. So like the code synchronizes with the screen refresh rate, and that effectively makes a really smooth animation. And smooth animations are better. So that's why we do this. So if that was too confusing, all you need to know is that this function executes every now and then to actually animate the scene. In our case, so the render function always takes one parameter called time. It doesn't have to be called time, but it usually is kind of intuitive to know because it is time. So the time is basically how many seconds, I think it was like nanoseconds or milliseconds, something like that, since the animation or like the website began. So we basically use this value to, in this case, rotate the cube. And then once we change the position or rotation of the cube, we say render.render. In other words, we tell the renderer to say, hey, okay, we moved the cube, so update the screen to show the newly rotated cube. And then we repeat this over and over. Okay, my mouse might die. If that happens, I'll have to like run out of the room and grab my charger. So sorry if that ever happens. All right, so that's actually it code-wise. So all we need is the actual website. And for that, all we need is this body, so the body of the website, and one canvas. All right, so if you have done that.
Someone asked the question in the chat.
Oh yes, it's an infinite loop. Okay, so now if you save this HTML file, and if you go to like whatever, if you're on a Mac, open Finder. If you're on Windows, open File Explorer. You should be able to open index.0html and see the animation in your browser. And actually, we did this workshop internally a while ago, and this is where a lot of people get errors. So if you have errors, try to debug it. If you can't solve it, tell me in the chat or either out loud, and we'll try to help you out. Actually, I got an error too, so I'll have to debug it myself. Oh no. Oh, can you scroll to the bottom of the code again? Oh, yes. Oh, and also real quick, I forgot to do something. So in the first line where it says script, you have to say type module, or else it won't be able to load 3JS. Just because that's how JavaScript is, and JavaScript is like one of the most confusing languages out there. Okay, mine is actually not working, so I'll have to debug it myself. Anyone else having issues? Hold on. Oh wait, I think.
I think a few people said they're seeing a black box and then someone's seeing a white screen. They put in the chat.
You click on whatever web browser you're using. Usually there's some option called inspect. Or actually, let me show it on the screen share. Hold on. Stop share, screen share. Okay, so I'm using Google Chrome right now. So if I right click and hit inspect, it'll show the developer tool. So if you go to console, if you have any errors, it'll show up right here. So usually if it's not working, it's because there's some error going on in the code, and it'll say what's wrong right here. Okay, I need to check myself what is wrong with my code. Oh, sorry, I think this might have to be Z after all. So when it says camera.position.y equals 2, that probably has to be a Z. There you go. So yeah, you should see something like this. You might see some different color depending on what color you specified earlier, but should look like this. There you go. All right, so now I can focus on helping people out. Anybody like stuck? Or if you're stuck, I guess like, so Daniel or Maxwell, Daniel, Sarah, are you guys still having issues? Oh, Sarah got it. Awesome. In the interest of time. Oh. Yeah, I guess we should. One last call for anyone that needs help. It says render has already been declared. I guess that error usually happens when you say const render. Choose. So that error usually happens if you say const render like twice. So after you say const render, you should never say const render again. Only like thereafter, always just say render. Like for example, right here, instead of saying like const render dot render, I just say render. Oh, Max, he figured out. All right, awesome. So yeah, like Kevin said, I guess in the interest of time, we'll have to move on. If you're stuck, you can, again, just copy and paste the whole code from GitHub and kind of follow along. So what we're going to do is, can you create a var is.js without? Can you create a var is.js without? Oh yeah, so I guess in our case, it didn't really have to be a const. We just made it a const just because. But yeah, it can be a var if you want. And actually, in the next part, we're gonna use var. Okay, so okay, so what we're gonna do is we're gonna copy index0.html, paste, and basically make a duplicate of it. All right. And we're gonna name it index1.html. So if you've noticed, when you ran the animation in Google Chrome or Firefox or whatever, you'll notice that the screen is a constant size. Like even if you have like a huge screen, maybe you have an ultra wide, or even if you have a phone, it's always the same like canvas size, which is bad because, you know, in modern websites, you want to make your design responsive. In other words, if you have a phone, you want to make your screen smaller to kind of fit the phone screen. If you have a really big desktop screen, you want to blow up the canvas to fit that big screen. So we are basically going to address that in the next part. So in index1.html, we're going to make several modifications to do that. And the first modification actually has nothing to do with responsive design. We're just going to organize our code a bit. So what we're going to do is we're going to move all the canvas, render, camera, scene, etc. into the first part of the code. So I'll paste the code in the chat just now. I'm going to do something like this. And the reason why is because from here on, we're going to have a lot of functions, like functions within functions and stuff. And if we declare, like say the canvas and render right here, we can't use the canvas and the render outside this add event listener function, which is kind of inconvenient. We want to be able to use the canvas, render, camera, etc. wherever we want. So we declare it up here. If you've done any CS courses, you know, it's the concept of scoping. We want to put this in like a more global scope. And similarly, we're going to say var object for sure. So what this is basically this is gonna be used to store all the objects in our scene, just like in a more organized way. And there's also another variable called var scale, which we may or may not use, but I just wanted to put it here. And you'll see what this does later on. All right, so now we move on to the code. So since we already declared a canvas up here, we don't need the const anymore. We just say canvas equals blah, 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 render equals blah, blah, blah. All right, so at this point, we're actually going to change the camera a bit. Right now, we have this thing called a perspective camera, which is how we humans perceive the worlds. In other words, something that's far away appears small, something that's close to you appears big. Instead, we're going to use something called an orthographic camera. So I don't know if you guys seen the Tech Gala banner that we kind of put in our event Facebook page. That's what an orthographic camera looks like. It kind of looks like those. I don't know if there's like a good way to explain it via words, but basically stuff, no matter how far it is away from you, looks like the same size. I guess you'll see in the moment when you actually run.
There are no vanishing points. It's another way to explain.
Thank
It
you.
looks like Pokemon.
Oh yeah, that's a good way to put it. It'll look like Pokemon, like the good old DS games, not the new ones. So I pasted the code for the camera in the chat just now, and that should go right here like this. Boom. And likewise, we don't need the const in this thing anymore. And just for a good organization, we're going to rename the geometry to geometry cube to be more explicit on what it is. I'm just going to call this material red. Or actually, this still does need to be const. Sorry. And also, we're going to change the basic material to something called Lambert material. So if you've noticed, the basic material is like ultra basic. It doesn't look 3D at all. It's just like one solid color throughout the entire scene. And that's not good. So Lambert material is more sophisticated. It actually simulates, shadows and whatnot. So it looks more like an actual 3D object. All right, so what we're going to do is we're going to say object.cube. So this basically stores the cube into the object dictionary we made earlier. So we say scene.add object.cube twice. All right, so another thing we want to do is we want to add a light to our scene. So by having a light, the 3JS knows, which side should be illuminated, which side should be the shadows, etc. And again, I'm going to paste the chunk of code in the chat. I'll make like a huge long dashed line so you guys know like where the code ends and where the code starts. So it should look like this. So to explain what's happening, I guess the variable names can explain themselves, but color is the color of the light. Intensity is how bright it is. And this part actually creates the light. And then we specify the position and target position. So basically which direction the camera is or the light is facing. And then this is for a later part that we won't get to yet. And then we add the light to the scene. All right, so we kind of got distracted with all the lighting stuff, but now we actually want to add code to basically change the size of the canvas depending on the size of your screen. So to do that, we're gonna call this function called Resize Canvas, which we'll have to code ourselves. So what we're gonna do is, hold on. We're going to add a new window dot add event listener. And this time it's going to be called resize. So it'll basically, what this will do is every time the window is resized, it will call the resize canvas function. Again, we will have to define what Resize Canvas is in a moment. Okay. All right, so function Resize Canvas. So first, what we do in this function, so again, this function is called every time your window is resized. So every time a window is resized, the first thing we do is remember the scale variable we declared earlier. So we say scale equals window dot device pixel ratio. So what this does is, let me actually open the Google Slides that explain what this does. Where did my Google Slides go? There it is. All right, so basically what this does is, first off, to kind of explain the background of it. So websites usually render stuff using something called a vector image. So basically vector images are like geometric shapes defined like sort of mathematically. And the advantage of that is no matter how much you like say zoom into the object, it's defined mathematically. So it always remains sharp and crisp. Whereas WebGL on 3JS uses something called a raster image. So that's kind of like the more traditional image where it's like defined in pixels. And the problem with pixels is that when you zoom in, it starts to look blurry. So there's like here's like a graphical representation of the difference between pixel images and vector images. So what the problem with WebGL and 3JS being pixel based is that say you like zoom into your image, or if you have like a really high resolution device, like the latest smartphone, it'll noticeably become blurrier. And that's because a lot of times in websites or like web browsers, there's this thing called a CSS resolution. So for example, in apparently Samsung Galaxy S10, the CSS resolution is 360 pixels. And what that means is when you open a web browser in your Galaxy S10, the code would think that the phone screen is 360 pixels wide. But in reality, the device actually is 1440 pixels wide, which is pretty high resolution. But again, the website thinks the device is 360 pixels wide. So it'll actually try to render whatever 3D scene you have in 360 pixels. And that'll look really blurry on your crispy 1440 pixel device. And this is where, with that in mind, that's where, let me swap screens again. With that in mind, that's where screen or window device pixel ratio comes in. So in our case, in the Samsung Galaxy S10's case, the CSS resolution was 360 pixels, but the device resolution was 1440 pixels. So the scale is 4 because the actual resolution of the device is 4 times the CSS resolution. And this is important because, again, the website thinks the device is 360 pixels wide, which isn't the case. So we have to like manually tell WebGL and 3JS, like, hey, you have to render whatever you have with 4 times the resolution because that's how high res the actual device is. So now that we have this, okay, that was a lot of talking. Let's get back to coding. So now that we have the scale, we say let width, so the width of the canvas is good. First, we obtain the width of the current width of the canvas. So this would be document.document.element.client width. So this basically obtains the width of your device. And same, but as for the height, just for the sake of, just because we're going to say it's going to be 650 pixels, that's just kind of like an arbitrary decision we made. If you want, you can make it like document.element.client height. So it's like exactly the same height as your screen. But for now, let's just hard code to be 650. So now what we do is we say canvas, remember that's canvas is where we're drawing our 3D scene. We're going to say the width is whatever width the screen was times scale. So again, in the case of Galaxy S10, the width was say 360 pixels and the scale was 4. So the actual width of the canvas is going to be 1440 pixels wide. It's going to be a huge screen. But the problem is if we make it so big, it's obviously not going to fit on the screen. So that's why we need this portion of the code. So this basically shrinks the screen back down to 360 pixels. So it fits in the screen. But the size, okay, this is a really confusing part. The size of the canvas is going to be 630 pixels wide, but the resolution is going to be 1440 pixels wide. So the screen, the canvas is still going to fit in your screen, but it's still going to be really high res. So if you ever have, again, really high res smartphone or something, it'll still look crisp. And while we're at it, we're going to actually add this line of code in between. So this basically tells the renderer like, hey, FYI, we changed the size of the screen. So kind of change your configuration. So, you know, you render to the correct size and resolution. And I don't know why all my code is like one space shifted right. There you go. All right, so now that we resize the canvas, we resize the render, now we can resize the camera without resize the camera in piece. So again, I'll paste this portion of the code in the chat because it's a bit long. Should look like this. So this part is the part that's basically changing the size of the camera, or more specifically, the aspect ratio of the camera. All right. Because say if you have like a really vertically long camera, but if you resize the screen to be horizontally long, you want to like change the aspect ratio of the camera to fit that. Okay. And one quick thing that you have to do is you have to go to this part between script and the body and add a style and say body margin 0. And that's because by default, everything in HTML has like a slight margin. So if we don't do this, what's going to happen is the canvas is going to kind of not fit in the screen because there's going to be a thin margin around the canvas, which doesn't allow it to fit in your computer screen. So we have to select, okay, don't add any margins. We want the canvas to fit snugly into the screen. And that's what this does. Right, that was a lot to process, but now if you follow the same procedures and open index1.html, you should see a canvas that fits exactly to the size of your screen. And I'm already facing glitches, so let me see what I did wrong. And again, if you face any issues, shout out or say in the chat and I'll try to get around ASAP. And in my case, it's probably because I misspelled Lambert. It's supposed to be Lambert. Oh, sorry, I just realized I forgot to text you guys the camera code. Okay, so I'm gonna actually debug live, so kind of give you guys like a hint of what can potentially go around. And also because you probably copied my code, you guys probably have the same glitches. So this should be geometry cube in material red to make sure it matches up with the names here. All right, cube is not defined. Oh, this should be object.cube, object.cube. Oh, hold on. If the scene, okay, so I'm going to show you what I'm seeing right now, because this is actually a pretty common glitch that I faced while I was preparing this workshop. All right, so you see this right here. You can see something's going on, but it's kind of, the cube's kind of clipped off, and that's because the camera is too close to the cube. So to fix that, I'm going to go back to my code and add this line right here, camera position dot set 0 for, or this should go before the render, camera position dot set 046. So this basically kind of moves the camera back. So it moves it 4 units up, then 6 units back. So you're like kind of more set back, you kind of see the cube in its entirety. And it's not working.
Do you need to adjust clipping planes?
Oh, no, it's because I forgot another line. It should be camera.lookAt. So you have to tell it to actually look at the cube. Sorry, guys. Okay, so if you've done everything that I showed you just now, you should end up with something that looks like this. So it's the cube ominously rotating around in a dark space. But the caveat is, as you can see, if I resize the screen, it actually fits to the screen. And I guess since I'm doing it on my desktop computer, which isn't really high resolution anyways, you can't really tell. But if you were to open this on like say a Surface Pro or a MacBook Pro, that's like a really high resolution, or I guess the more technically correct term is a really high DPI, you'll really notice the difference of like all the scaling thing we did earlier. Alrighty, anyone stuck? Need help? The sides are all the same shade. Oh, so if the sides are all the same shade, I'm guessing you didn't update the basic material to a Lambert material. So make sure you have a Lambert material, because a basic material can't like understand the concept of shading. All right, we'll give it like a minute for people to kind of catch up, or if you're done, kind of just relax because it's been a lot of talking and coding. I don't have a cannot test properly width of null. Oh, okay. So, cannot test properly width of null. Let me go back to my code. Width of Does this say which line it's giving that error, Sarah? It usually says like line or 79. So it should be around this area. Oh yeah, good point. Canvas has to be up here. So that error basically means canvas is like not defined properly. So the flow of the code should be we declare canvas here, then we define canvas right here, then we use it down here. A different law, different error. That means progress. You know, it's kind of like a running joke in CS. New error, progress. Anyone getting fatigued, by the way? Do you guys all want to like take like a 3-minute break or something? Because this workshop, again, we did it again. We did it a while ago internally, and it was pretty intense back then also. So I guess I'd say give it like we'll have like a 5-minute break. Just so I'll kind of relax and I guess watch some funny YouTube videos and chill. Oh yeah, so we are kind of, I guess at this point we're kind of crunching time anyways. So we'll like take a 5-minute break, and then if anyone wants to stay overtime, we'll go on to do some like more fun stuff. And I guess next time we should probably design this workshop to be like a 2-hour workshop. Oh yeah, thank you, Kevin. How's the workshop, by the way, guys? Like, is it like too fast paced, slow paced, too confusing? You guys like wanted more like visuals or like more slides or something? Ooh, silence. Maybe we should play elevator music. Oh, thank you, Max. Oh, a bit too fast. You're right.
Sir, are you
Just
still getting the error?
Yeah, I'm like fixing things and like getting different errors. So I'm just going through the code and trying to like compare
You
it
want
to
a screen
the
share?
GitHub. It's okay. I'm just going through
Sure.
the code on GitHub right now.
Okay.
Yeah, thank you though.
Yes, this has been kind of like a running thing though, because this is a bit of a hard workshop. Maybe it was kind of a bit of a false marketing when you said it like beginners welcome.
Beginners are welcome.
But
Welcome to
welcome.
walk through the fire that is WebGL. Welcome to get tested. Welcome to try their hardest on the welcome to sacrifice their sanity at the volcano of 3D rendering. WebGL is hard. Koa, do you have any questions, by the way? If you want to go back to the beginning. Okie dokie.
Is the function render supposed to be outside of the load event listener? Or does it not matter?
I'm sorry, what was that again?
The function that we have called render that takes in time, does that need to be outside of the add event listener for load?
Oh, so I guess in the code I just demonstrated, it's not. So it's okay either way at this moment, at least. But I guess
Okay,
for
okay.
organization's sake, it looks better if it's right below the add event listener resize, like you said.
Okay, I'm just trying to figure out why mine isn't working.
Do you want a screen share? We might have time.
2 minutes.
I guess if we have time.
Smoky, do we have time?
Like 2 minutes until break-ins. I guess that's enough. We have time.
It's a no. Oh, wait, is that yes or no?
It's a yes.
It's a yes? Oh, let's go. Okay, go ahead, Daniel.
I was
Let's
muted,
see.
my bad.
No problem.
I was
So you
comparing
have,
it with like the GitHub and I got to about like here. So it's probably somewhere over here.
So if you open the developer tool, does it give any errors or is it just like,
No, it just has like the black like canvas but no cube.
looks like Sarah has the same thing.
Yeah.
Actually, can you scroll back up to like the first few lines? Okay, 3, let's see.
What is the line 32 to 42? Like, why is it an object like that?
In
Is
like
there supposed to be
Just
a
this?
for
function?
scoping reasons.
Oh, sorry. Oh, just for scoping?
Reasons. Yeah,
Oh, okay. I wasn't there for that part. Sorry. Wait, is that how it works? What? Really?
This
that's
is
what
what the GitHub code has too, so
Okay. Do you
Hmm.
have to, wait, sorry, I don't know too much because I was eating dinner, but do you have to have request animation frame be at like 56 and 59?
Yeah,
Yes.
You do? Okay.
because that's what makes it an infinite loop.
Wait, let me go look at the GitHub code.
It looks all right to me. Not sure what it's not rendering.
It seems like multiple people are getting this problem.
Yeah. When I
Oh wait,
run,
okay. Wait, scroll back up. I just noticed one thing. Okay, go back up a bit.
up,
I don't
No.
think render is inside of the load event listener on GitHub. Is that
yeah,
different?
that's the thing I was asking about, but they said it didn't matter.
Are you sure it doesn't matter?
Let me
Tony?
take it out.
Yeah, try.
Because on mine it worked when it was inside.
I think it might be an
Really?
async thing.
How would it know it if it would work, right? Because it's doesn't it have to be outside because it's a lifecycle function, right? Okay, IDK, give it a go.
Yeah, it doesn't work. Is this resize thing correct? Yeah, I mean, we could just continue and I could like just keep trying. It might
Yeah.
be something here though. I think
Oh,
it's actually
window
this.
device P cell ratio in line
Oh
67.
wow.
Is that it?
It could be. And then is there also supposed to be like a semicolon here?
Don't think so, no.
Oh, in the
I don't,
GitHub code, it seems like it is.
I don't think it matters, actually.
Yeah.
Okay, let me just try it now.
Mhm.
Okay, it works now. Thanks.
Yay.
Yo, let's go.
That was such a dumb error.
No, it's okay.
After the
Sublime
break, we have a lot of
text.
fallen soldiers.
Uh,
We'll chug on.
Sarah, did you fix your thingy?
No, you just fixed the typo in pixel ratio, right?
Uh-huh.
I did not have that typo and mine is still.
Do you have the render function nested in the load event listener, like Daniel did?
Yeah.
What
Should
Richard said also, that's correct. You could do that, yeah. Do you want to screen share, Sarah?
Sure. Did you say this should be
Did
outside?
you? I think you need to request animation. Oh, you did.
Yeah.
Well, it didn't change his when it was outside, but I thought it had to be outside. I don't know.
I think I also tried moving it outside and it didn't change anything.
Oh wait, hold on. Camera position or camera depth positions are set. It should be a 4.
I had it as 4 before and it was working, but someone suggested 0. So I tried that.
It should probably be 4 because
Yeah.
You wanted the isometric view. I don't see any errors here. I don't see anything here either. Wait, perspective camera instead of orthographic? Is that what you guys wanted to do?
Oh no, it should be orthographic.
Yeah, I think so.
Oh, and then the numbers are going to be different. The constructor is going to be different.
What do I change?
I can copy paste the code.
Bye, Koa.
Sorry, it's formatting this. Yeah, so it'll be negative 0.5, 0.5, 0.5, negative 0.5, and then 0 to 1,000. So it won't be like FOV aspect near and far anymore. So you can just delete those.
Okay.
And, if you want the details, I think it's like left, right, top, bottom, or something like that.
Okay, now it's working. Thank you.
Yeah.
Awesome. Let's go.
Kevin, do you want to like go straight to importing models because it's already kind of overrun?
Okay.
Were you trying to say something, Daniel?
Yeah, I mean, I was just wondering if the camera.zoom and the camera.update projection matrix were not necessary, or because I feel like I didn't see it in Sarah's unless it was just like a lower line or something.
So you might still be able to see it even if it's not zoomed properly. And then I think the resize automatically updates projection matrix when you resize the window. So that probably like fixed it for her.
Oh, okay, cool, thanks.
Tomoki, do you want to like run quickly through the other slides about shadows and stuff, and then we can do models?
So I guess we have to skip over the coding part because of time issues. But one thing that it was initially planned on doing was adding shadows to. Oh, we'll actually also do that in the next part. But I guess to kind of quickly go over what was planned to happen. Or we did that. So we got this part. So right now the scene looks really boring. That's because there's no shadows, right? It's just like blocks just floating in the air. So in computer graphics, how shadows usually work is by basically treating the light source as a camera. So what would happen is the light would have a camera and it'll look in the direction that the light is beaming out. So, and basically whatever the camera can't see, because it's like being blocked by an object or something, that's where the shadow should be. So in this case, there's a light and like pretend there's a camera facing direction of the light. And this is the region it can't see because it's being blocked by this orange cube. So that's where the shadow should be. And that's how computer graphics usually render shadows. And 3JS obviously implements that. So if we did have time, what would happen is I'll go to like programming index.html and show you guys how to add shadows and all. But well, unfortunately, I have to skip that and go straight to the next part, which is importing models. So by default, 3JS only has really basic shapes like it, like cubes, circles. It's not really interesting. So we want to import 3D models from other softwares to make more elaborate scenes. And that's what we're going to do in the next part, which Kevin will lead. So I'll hand off the mic to him.
All right. So for this, there's a couple of other things that you'll have to get before we can get started. So make sure you have the, can you guys see my screen, by the way? Okay, so make sure you guys go to the GitHub and download this .glb file. So that actually contains this model from the TechAl banner, which we'll be importing to 3JS. And then in the interest of time, please just copy paste the index-2 file. So we're going to build on top of that to create our index-3 file. All right. So we're going to start with a fresh copy of index-2, and then we're going to make a couple modifications to import a model instead of using our mesh that we create inside 3JS. So like Tomoki said, kind of the reasoning behind this is that we don't want to manually create all of our models with lines of code. We want to be able to use a program like Blender to export a model and have it automatically come up in 3JS. And along the way, we're also going to add some things like controls and things like that. Don't know why this is not working. That's not good. Okay, this should be fine. Okay, cool. So the first modification that we're going to make is that we're going to import Gltf Loader. So this is a separate like package from the rest of 3JS, and basically what it's going to do is give us some tools to be able to import models from this file type. So this file type is a way to a standardized way to like encode a 3D model with things like compression and stuff like that. So we can do that with just this one line underneath our first import statement. And the next thing we're going to do is we're going to come down to line 37 in index2.html, and we're going to replace the part where we create our little cube mesh. So instead of creating a mesh with the Three.js things, we're gonna use what's called a loader. So we're gonna create a new variable here instead called loader, and make it a new loader. We're gonna use that loader to load our GLB file. That's gonna be sculpture.glb. And it has a bunch of other options. So one of these is a callback function, which will run after the model is actually imported. And in this callback function, we're going to do a couple of things. So first thing we're going to do is get our model from the scene. So right now it's just going to take the entire scene, and we're going to start it as model, and then we're going to set the position of that to 0. And we're also going to add that to the scene. And then there's a couple other parameters like an error callback, which we will just really quickly log here. And you guys can feel free to copy some of this code from GitHub, since I know it's a lot to type.
Oh, Kevin, real quick, can you zoom in so it's easier to read the text?
My bad, sorry.
Thank you.
Is that okay?
Yeah, that's good.
Okay, cool. Sorry. And so now we can delete this mesh part, and make sure to add this let here because we were reusing the same variable to make sure it didn't cause any errors. Okay. Next thing we are going to do. So we're gonna move our lights a little bit because this model is gonna be slightly different. So you can just copy the numbers from GitHub. We're just gonna move this 10 to a 3. Target it at 0, 0, 0. And I'm gonna actually increase the shadow resolution a little bit just so it looks better. These are all optional. And then, so one important thing about our model import is that, so JavaScript is asynchronous, which means not everything happens in the order that you write the code, essentially. So we want to be able to, instead of starting our render loop after all this code runs, in which case the model might not have been loaded yet, we want to start a render loop after the model loads. So we're going to put our render function start in here instead of at the bottom of the function. So I'll just I'll cut this out from down here and move it up here. Yeah. So we also have to fix our render function since this is all code from the old mesh. So a couple things we're going to do. Instead of storing it in object.cube, we can store this in object.model. And this kind of seems redundant right now, but we'll change this a little later. And this should, so just as a sanity check, we should try running this right now just to see if the model imports properly. So we can go back and see if the model changed. It did not. Let's see what's wrong. Oh, okay. My bad, I missed an error. And you can see we have our fancy little model up here at the top, and it's rotating. So we're going to do a couple other things just to make this a lot prettier. The first thing we're going to do is in our loader function, we're going to basically iterate through all the meshes that are imported, and we're going to kind of change those around and give them proper materials in Three.js. So I would definitely copy paste this code from the GitHub. So we're just going to replace, I think it's probably easiest to just replace the entire loader function with our new function, and I'll explain what's going on. So you'll see that we still have our old stuff here, but in the middle here, we're traversing through all the children in the model, and we're kind of checking each mesh, and we're setting the materials. So this first one is in a new type of material called a normal material, which basically sets the colors based on which direction each face is pointing. You'll see what that looks like in a second. And then we have a standard material that's just a gray color with some roughness and middleness applied to it, which will give it a bit of shininess. And we also have to make sure that these meshes can cast and receive shadows. All right, so now if we go back to our file and refresh the page, you can see that, well, I can't really zoom in, but you should be able to tell that the models now have colors and they look nice and fancy. Another thing we're going to do is, I might want to zoom in and kind of inspect this model more closely. So we're going to add what's called a control, orbital controls. So that's pretty simple. All we need to do is import orbital controls up here. We're going to set them up right underneath where we set up the camera. So what this does is it makes a new orbital controls object that takes in our camera and our the canvas element, and it'll kind of capture our mouse inputs. We're setting it to look at the center of our scene. We're disabling panning and we're enabling damping, which makes the controls feel a bit nicer. And one more thing we do to do that, we have to go down to our render function, and we're going to add one more line which says controls.update, so just updates all of our controls, and we're going to move this position stuff up here. So earlier we were constantly updating the camera position every time we rendered, but since the controls are going to kind of hijack that, this will just be like the initial position instead. So we can save that and go back to your HTML. Oh, I probably made a typo again. Oh, okay. We just need to add our controls, or define our controls up here so that we can access it later. And now if we refresh, we should see this. And if we click and drag, we can zoom in and look at our model in all of its glory. Yeah, so you can ignore these kind of red lines everywhere. That's like a camera helper down here. So yeah, there you go. Here's our model. We can do stuff like we can move it down so that it's actually touching the floor. We can manipulate it in different ways. So we can have just the top turn instead of the entire object turning, which is what it's doing right now. But I think in the interest of time, we can skip all of that. Do you guys have any questions? All right, see ya. Sorry, my chat is kind of fucking up.
Thank you guys for coming.
Yeah, thanks for coming.
Yeah, thanks. Yeah, again, that'll be it for today. Thank you again, guys, for coming. If you guys have any follow-up questions, feel free to hop into our Discord, etc., and we'll help you guys out if you want to know how to move on from here and stuff like that. All right, so I guess everyone have a nice night. Hopefully we see you
what's the
around.
Discord? The ACM Discord with the design channel. Yes.
I was hoping that would be the link.
It's on the website at the right there.
Oh, okay. There you go.
Third from the right.
I'll copy it into chat. All right. See you guys.
See y'all.
All right, thanks, y'all. Take care.
Thank you for coming.